Exercise number 2 of permutation and combination. Okay, to question number 1. So the object list, if you read the problem, it is 1, 2, 3, 4, 5. We need to form a 3-digit number. Okay, so first part, repetition is allowed. So this can be occupied in 5 ways because there are 5 numbers 1, 2, 3, 4, 5. Any one out of this 5 can be utilized over here. This again 5 and this also 5. So total 125 ways. Okay. Second part, repetition is not allowed. So this is 5 because there are 5 objects. One object cannot be utilized in the second place because it is utilized in the first place. So there are 4 objects left and this is 3. So this is 5 into 4 into 3. Okay. Or else you can also do 5p3. 5 objects in 3 places. Okay. In the second part, we'll get the same answer. Question number 2. Sub question 1. How many 4-digit numbers can be formed in which all digits are different? 4-digit number. So this can be occupied with 1 to 9. There are 9 ways. Okay. All different digits. 0 cannot occur in the first place. A 4-digit number cannot start with 0. So these are 8 ways because 9 is reduced by 1, that is 8 ways, plus 1 way because now we can include 0 over here. 0 also can be a part of this box. So these are 9 ways, these are 8 ways, and these are 7 ways. We are reducing because repetition is not allowed. So 9 into 9 into 8 into 7. Okay. 4536. You can check that on a calculator. Okay. Second sub question two, you can take it for self study. Okay. It's not 33, it's 3. Yeah. Third sub question 1. How many 3-digit numbers can be formed without using the I would like to discuss second sub question 2 before we start with this because 2, 3, 5, 6, 7, 9. This is not supposed to be used because they are saying without using these digits. So the object list is 1, 4, and 8. Okay, and 0 also. Okay, so 3-digit number 1, 4, 8, 3 options. This will be 2 options plus 1 because now 0 also can be included. So these are a total of 3 options, and this is 2 options. Okay. So this is 3 into 3 into 2. That is 9 into 2, which is 18. Okay. I think there is some error in the problem. I'll just recheck it. Okay. Yeah. Question number 3, sub question 1. How many 3-digit numbers can be formed using the digits 0, 1, 3, 5, 6, 7? If repetition is not allowed, if repetition is allowed. So in first do repetition is not allowed. 1, 3, 5, 6, 7, 5 ways. Since repetition is not allowed, this will be 4 ways plus 1 because now 0 can be included. So this will be 5 ways and this will be 4 ways because repetition is not allowed. So 5 into 5 into 4, that is 100. Now in the second case, when repetition is allowed, so this will be 0, 1, 3, 5, 6, 7. 6 ways and this also will be 6 ways. So this will be 5 into 6 into 6, which is equal to 180 ways. Okay. Question number 4, sub question 1. Okay. How many two-digit even numbers can be formed from the digits 1, 2, 3, 4, 5? So we are requiring a two-digit number without repetition. Sorry, first one is with repetition and the second one is without repetition. So we require a two-digit number. U is the units place. Okay. So the units place will have object list is clear. Huh? There is no zero in the object list. 1, 2, 3, 4, 5. So only 2 and 4 can occur over here. 2 or 4. So this is two ways. And here 1, 3 and 5. 3 ways. Okay. 3 ways. Plus now both will not be occurring simultaneously over here. We'll use any one out of this two. So the other one can be utilized over here. So that is one more way over here. So these are 4 ways. Okay. So the 3 odds and the 1 even which is left. Right. So this is 4 into 2 which is equal to 8 ways. Okay. Uh, just a second. This one will take it for no repetition. Huh? No repetition. So ideally this is the second sub question. Second sub question. Right. And in the first sub question, 2 and 4 can occur over here. So this will be two ways, two digit number. Here anyone out of the 5 can occur because repetition is allowed. So 5 into 2 which is equal to 10 ways. Okay. Let me go back to that second sub question too. Uh, the object list is 2, 3, 5, 6, 7 which cannot be used. 7, 9 which cannot be used. So we can use 1, 0, 1, 4 and 8. So this is the object list and we require a 3-digit number. Now see guys, they have not mentioned anything about repetition or not. So we'll consider that repetition can be allowed. Okay. So this can be used in filled up in 3 ways. Okay. 0, 1, 4, 8. Now 0 also can be included. So this is 4 ways. And this is also 4 ways. So 16 into 3, which is equal to 48. So earlier I did not read that. They have not mentioned anything about being repetition allowed or not allowed. So we are considering repetition is allowed. Okay. So that clears this second sub question too. Yeah. Fifth one, first sub question from the fifth. How many 3-digit odd numbers can be formed? Okay. So the object list is 1, 2, 3, 4, 5. So in the first part, it's a 3-digit number, so 3 boxes. Repetition is allowed. Okay. So 1, 3, and 5 may occur over here. So these are 3 ways. Here and here, this will be 5 ways and 5 ways because 1, 2, 3, 4, 5, anything can occur over here. So 5 into 5, 25 into 3, that is 75 ways. Okay. And in the second part, let us just understand the second part very clearly. Okay. So 2 and 4 will be there. That is 2 ways. Plus, now there are three options over here. At a time, only one will be utilized. The other two can be utilized here and here. Okay. So two odd which are left. Okay. So this is 4 ways, and since repetition is not allowed, these are 3 ways. One way we have reduced. So 4 into 3 into 3. 9 fours are 36. Okay. So sixth problem, you can take it for self-study. Let's go to the seventh problem. Seventh sub question 1. The object list is 0, 1, 2, 3, 4, 5. Okay. And 3-digit odd numbers we require. Repetition is allowed. So 1, 3, and 5 over here. Okay. Here it will be 1, 2, 3, 4, 5. 0 cannot come over here. So these are 5 ways. These are 3 ways. And here will be 0, 1, 2, 3, 4, 5. So these are 6 ways. Okay. So 30 into, let me read the question once again. 0, 1, 2, 3, 4, and 5. Repetition is allowed. So there are 3 ways at the last place. 1, 3, and 5. Odd numbers it should be. First will be occupied with 5 ways. 1, 2, 3, 4, 5. And the second one will be 0, 1, 2, 3, 4, 5 because the repetition is allowed. So 6 ways. 5 into 6. So that is, I think, 90 ways. Okay. And the repetition is not allowed. Second part is repetition is not allowed. Okay. Yeah. So 1, 3, and 5 over here. So these are 3 ways. Okay. This will be 2 and 4. So these are 2 ways. Okay. And all three are not utilized. So two odd can occur over here. So these are 4 ways. Okay. 4 will reduce to 3 because repetition is not allowed. And 3 will be added with 1 because now 0 also can be a part of this. So one more way gets included. So this is also 4. 4 into 4, 16 into 3, that is 48. Okay. The first subpart is showing answer as 100. So I think we are getting 90 as the answer. 100. Not very sure about it. Yeah. Question number 8. Sub question 1. How many numbers between 99 and 100, both excluding, can be formed such that every digit is either 3 or 7? See, now between 99 to 1000, whatever number is there, that is a 3-digit number. And 99 is 99,000 both excluding. We cannot include those numbers. So we have to frame a 3-digit number. Now the first part says that every digit is either 3 or 7. So 3-digit number, 3 places. So this will be 3 or 7, 2 ways, 2 ways, and 2 ways. Repetition can be allowed. Now, they have not mentioned anything about repetition being allowed or not. So 2 into 2 into 2, which is equal to 8. Second one, there is no restriction, as in you can frame any three-digit number. So this will be from 1 to 9, 9 ways. This will be 0 to 9, 10 ways, and this also will be 0 to 9, 10 ways. Okay, so 9 into 10 into 10, 900 ways. Second part, repetition is not allowed. Third part, sorry. In the third part, repetition is not allowed. So we'll solve that. Now, first place will be occupied with 1 to 9. Obviously, 0 cannot come in the first place. Since repetition is not allowed, 9 becomes 8 plus 1 way. Because now 0 can be a part of the second digit, second place over here. Okay, so that's why we are adding 1. So this is equal to 9 ways. And it is that 9 to 8 because repetition is not allowed. So 9 into 9 into 8 ways. That's 81 into 8, 648. Fourth one, the digit in the hundreds places 7. See guys, we know for sure that the hundreds place is 7. So we're not going to count that place and count that digit. So that's already occupied with 7. Okay. Second place. Third place. So 10 into 10, 100 ways. Okay. Fifth one, the digit in the tens place is 7. So 7, that particular digit is fixed in the place number 2. So this will be 1 to 9, 9 ways, 0 to 9, 10 ways. So 9 into 10, that is equal to 90. Sixth one, 7 does not appear anywhere. So 1 to 9 except 7. So 9 minus 1 way, that is 8 ways. 0 to 9 except 7. And this is also 0 to 9 except 7. So these are 9 ways and these are 9 ways. Okay. So this answer is also 648. 8 into 9 into 9. Seventh one, 7 is in the units place. 7 is in the units place. 1 to 9, 9 ways. 0 to 9. See, 7 can be repeated. They have not mentioned anything about 7 not occurring in the other places. Okay. So these are 10 ways. So 9 into 10, that is equal to 90 ways. At least one of the digit is 7. Okay. Now this is quite tricky. The last part. 8 1. So see, total three digit numbers. Okay. Without any restriction. So this will be 1 to 9, 0 to 9, 0 to 9. 9 ways, 10 ways, and 10 ways. So these are total 900 numbers. Step 1. Step 2. Numbers where 7 does not appear anywhere. Okay. Total number of three-digit numbers where 7 does not appear anywhere. These are 648 numbers. Okay. How I got the solution? It is in sub question 6 of the same problem. Okay, this is step 2. And step 3, okay, at least 1 7 is equal to total minus none. Okay, total number of ways are 900 minus 648. Okay, so that is equal to 252. So from the total number of numbers, I am subtracting numbers where 7 does not appear. I'll get at least one time 7 occurrence. Okay, yeah. Question 9 and question number 10, question number 9 and question number 10, you please solve as per the methods which I have taught you all in exercise number 9 of this particular chapter. Exercise number 9, okay? So right now, there is no need to solve this. 9 and 10, you solve in the last exercise. Okay? Yeah. Just a second. Let's go to question number 11. Yeah. 11 sub question 1. In how many words, with or without meaning of 3 English alphabets can be formed? And how many will have distinct alphabets? This is very simple basically. First part, 1, 2, and 3, A to Z, A to Z, A to Z. So this will be 26, 26. This is with repetition. Okay. And second part is all different. So second part will be 26, 25, and 24. So to multiply all this. Second part is without repetition, distinct alphabets. Okay. Yeah. Question number 11, sub question 2. Okay. So two cards are drawn one at a time and without replacement from a deck of 52 cards. Determine the number of ways in which cards can be drawn. Okay. What will be the number of ways if the first card is replaced before the second one is drawn? So part 1 or A part is without replacement. Card number 1 and card number 2, these are cards. So there are 52 cards, so anyone can be drawn. Okay. And second time when we are drawing one card, there will be only 51 cards. Because first time in the first part, A part, the card which we are drawing does not go back into the pack of cards. So now we are having only 51 options. So this is 52 into 51, okay? And the second part is 52 into 52 because B part. The first card is replaced before the second one is drawn. So second in the second draw again we are having 52 cards. Fine. Yeah. Next one, question number 12. Question number 12. Sub question 1. In how many ways 8 children are to be seated on a bench? In how many ways they can the children be seated? Okay. So now n is equal to 8 children, r is equal to 8 places. So npr 8p8 8 factorial ways. And by the way, NPR formula you all know, right? N factorial upon n minus r factorial. You can apply this, but then if the number top and bottom is same, you can directly write that number factorial. Second part, okay. Youngest person is sitting over here. The youngest person. Okay. So these are the 7 places left. And there are 7 different persons. But then the youngest person is sitting to the extreme left. Okay. Right? So arrangements will occur only over here. Here, the person is also fixed and the place is also fixed. So don't consider that particular box and that particular person. Y is the youngest person. Okay. So n is equal to 7 people who are remaining, 7 children who are remaining. R is equal to 7 places. NPR 7P7, 7 factorial. Okay, fine. Yeah. So that was question number 12. Question number 13. A number lock on a suitcase has 3 wheels, each labeled with 10 digits from 0 to 9. So it's a lock on a suitcase, right? If the opening lock has a particular sequence of 3 digits, okay, with no repeats, how many such sequences are possible? So see, it's a lock on our suitcase, and there are 3 digits. Okay, each particular thing has a number from 0 to 9. So the first one will be from 0 to 9, 10 ways. See, now we are not creating a number. It's not a 3 digit number. It's a 3 digit lock. So the first digit can be 0. We are creating a lock, right? It's a locking system. Okay. So 0 is allowed in the first place over here. So there are 10 ways to make this first sequence. First place, select the first place. From 0 to 9, any one of the digit can be used. Second one will be 9 ways because repeats are not allowed. Okay. And the third one will be 8. So 10 into 9 into 8. Okay. That is the answer. 14th one. How many different code words are there such that there are two distinct alphabets followed by two distinct non-digits, non-zero digits? Okay. So there are two parts in the problem. First part. So there is a code word. So here there are letters and here there are digits. Two. Distinct means different. So repetition is not allowed. So this is A to Z, 26 ways. So this will be 25 because repetition is not allowed. Now for the digits, two distinct non-zero digits. So this will be 1 to 9, that is 9 ways. And this will be 8 ways because repetition is not allowed. Distinct word they have used. Okay. So you have to multiply all this, you'll get the answer. Second part of the same problem. So the first two are letters and the second one are digits. So this is A to Z, 26 ways, 25 ways. So it has to have a odd integer, end with an odd integer. So 1, 3, 5, 7, 9, and it's non-zero digits. Huh? They are set in the problem. So these are 5 ways. This will be 2, 4, 6, 8. 4 ways plus. Now out of this five, any one will be utilized. So 4 will be left. That can be utilized in the first place. 4 even numbers, 4 odd numbers. Already there are 2, 4, 6, 8. That is 4 ways. And the 4 which are left over here can be utilized in the first place. So this is 8. So 26 into 25 into 8 into 5. That is the answer. Okay. 15th one. 60 boys and 40 girls are there. In how many ways can a president, vice president, and secretary and treasurer can be chosen if the secretary must be a boy, treasurer must be a girl, okay, and vice president can be anyone, as we read. President and president can be anyone, okay. So a secretary can be chosen in 40 ways. Treasurer can be chosen in, oh sorry, secretary can be chosen in 60 ways because there are 60 boys. Treasurer 40 ways, okay. Now one boy and one girl is already gone because they have already become the secretary and the treasurer, okay. Now president. Now the total kids in the class are 98. Okay, because out of 100, two kids are gone. They are holding the position of secretary and treasurer. So for president, there are 98 places left, 98 choices, not places, 98 persons are there who can contest for being the president. Okay, and for vice president, okay, there will be 97 persons because out of 98, one will be chosen as the president. So there will be 97 more choices for vice president. So you have to multiply all this, you'll get the answer. Let's check using a calculator. So it is matching with the answer which is given in the worksheet. That was question number 15. Question number 16. There are 6 flags of different colors. How many different signals can be generated by hoisting the flags on a vertical pole, one below the other, if each signal requires the use of at least 4 flags? So case 1, at least 4 flags are required. So there will be 4 flags, a signal of 4 flags. So these are flags, okay, one below the other. Flag 1, flag 2, flag 3, flag 4. Flag 1 and flag 2 and flag 3, and they are one above the other. Flag 1 can be selected in 6 ways. Flag 2, 5 ways. Flag 3, 4 ways. And flag 4, 3 ways. See, flag 1 is the topmost flag. There are 6 options available with us. So we can use any one of the flag over there out of the 6. Okay. Now if red flag is selected over here, now again, we cannot use the red flag. So we have to use flags which are having the other colors, 5 different colors. Okay. So in flag number 2, there are 5 choices, then 4, then 3. So this is 6 into 5 into, because it is flag 1 and flag 2 and flag 3 and flag 4. 6, 5, 4, 3. So these are 360 ways. 6 into 5, 30, 30 into 12, 360 ways. Now, if there are case 2, if there are 5 flags, at least 4 they are saying, no? So it can be more than 4 also if there are 5 flags. 1, 2, 3, 4, and 5. So 6 ways, 5, 4, 3, and 2. So this will be 720 ways. Okay. And case 3, 6 flags, at least 4 flags. So it can be, you know, 4 or more than 4. So 4, 5. This is case 3, which is of 6 flags, one above the other. So this is 6, 5, 4, 3, 2, 1. So multiply all this also will be 720. So yeah, you have to add all the 3 cases, case 1, case 2, and case 3. We'll get the answer. Okay. Question number 17. How many odd numbers less than 1000 can be formed using the digits 0, 4, 5, and 7? So less than 1000, it can be a single digit or a double digit or a triple digit number. So case 1, single digit. Object list is very small, 0, 0, 4, 5, and 7. So case 1 has 2 options, 5 and 7. Okay. Case 2, odd numbers, huh? Double digit. So it's a 2-digit number. So there are 2 ways over here. And here it will be 4. 0 cannot occur over here. 0, 4, 5, 7 में से 0 cannot occur over here. So this is one way plus one more way. Because out of 5 and 7, only one will be utilized over here. The other number can be utilized over here. So one more way over here, that is equal to 2 ways. So 2 into 2, which is equal to 4. Okay. So we are doing the second part first, that is with, sorry, the first part first, that is without repetition. Okay. Case 3, 3-digit number. So 5 and 7 over here, 2 ways, 4 over here, one way plus one way. Because out of 5 and 7, only one will be utilized. The other number can be given to the first place. So 4 is one way and one odd left. So this is equal to 2. And since repetition is not allowed, this will be 1. Okay. But now 1 will be added to one more 1, because now 0 also can be a case. Okay. So this is equal to 2. So 2 into 2 into 2, that is equal to 8 ways. So 8 plus 4. 8 plus 2, that is 10. And case 2, the answer is 4. 10 plus 4, which is equal to 14. So this is for repetition is not allowed. Okay. Now for the repetition is allowed part. For the repetition is allowed. Okay. And we are framing only odd numbers. So that's why 5 and 7 is towards the end. Okay. So this part will be 4, 5, 7. 3 ways. So this is equal to 3 to the 6. Okay. And here this will be 4, 5, 7. 3 ways. And here it will be 0, 4, 5, 7. 4 ways. So the total over here will be 3 into 4 into 2. 24 ways. So 24 plus 6, 30 and 2, 32. So when the repetition is allowed, the answer is 32 over here. Fine.